More than 10,000 species of these ancient marine predators previously roamed the Earth. Learn about their lives, how they died, and how much we know about them now. Ammonites, ancient marine predators with squid-like tentacles spreading from the characteristic multicumbered shells, were once among the most successful and diversified organisms on Earth. More than 10,000 species have been discovered from fossils found practically everywhere on the Earth where seas once existed, from the Great Plains of North America to the Himalayan foothills and Antarctic glaciers. Ammonite is the common name for ammonoids, a large and diverse group of creatures that emerged around 416 million years ago during the Devonian period. Other cephalopods, such as squid, octopuses, and cuttlefish, are linked to ammonoids, and they were early relatives of the contemporary nautilus. True ammonites, on the other hand, are a suborder of ammonoids that didn't develop until the Jurassic era, some 200 million years ago. Ammonites have survived 3 great extinctions throughout their lengthy history, the most recent of which being the Permian extinction, which was caused by volcanic activity around 252 million years ago and destroyed 96% of the planet's marine life. While many ammonite species perished in the extinction event, scientists believe the survivors evolved rapidly over the next million years. Ammonites roamed the planet's waters until they were killed out by the same 66-million-year-old catastrophe that took out the non-avian dinosaurs. Ammonites were found in a broad range of sizes and forms, from as tiny as an inch to as enormous as 9 feet wide, according to the fossil record. The shells of certain ammonites were long and straight, while others possessed helix-shaped shells. The majority of species, on the other hand, possessed coiled shells with increasingly bigger chambers separated by narrow septa. As the creatures grew older, they developed new shell material, but their bodies remained in the outer chamber. The shell was protected from being crushed by the walls that divided each chamber. Sutures were used to link them to the shell, and the intricacy of these lines varied greatly during the history of this animal. The many chambers in these cephalopods' shells most likely assisted them in gliding across the planet's warm, shallow oceans. The air was pushed into the inside chambers of the shell by a thin tuber-like structure called a siphuncle, which experts believe helped give buoyancy and transport ammonites through the water. However, it's unknown if ammonites were good swimmers. Ammonites, like contemporary cephalopods, were thought to have soft body tissue with tentacles connected to their heads for collecting prey, according to scientists. They possessed sharp, beak-like jaws to trap plankton, crustaceans, and other ammonites, according to fossil evidence. Larger reptiles and fish preyed on them as well. Ammonites' shell structures got smaller, more tightly coiled, and more complicated as the Mesozoic era progressed, between 252 and 66 million years ago. Sutures on early ammonites had simple lines tracing across their shells, but sutures on Cretaceous ammonites 145 to 66 million years ago produced elaborate patterns that may have allowed later ammonites superior buoyancy control. 66 million years ago, during the planet's most recent major extinction event, the ammonites died out. A 7.5-mile-wide asteroid blasted into Earth in the latter days of the Cretaceous, wiping out more than 3/4 of all life on the planet. Some experts believe the ammonites didn't survive the aftermath because their major food source, sea plankton, suddenly declined. Ammonite shells are now utilized as index fossils, allowing other fossils found in the same strata of marine rock to be dated. Because they are prolific, ubiquitous, and their many species lived over separate time periods that can be clearly identified by their suture patterns, cephalopods provide excellent index fossils. Ammonite fossils also give information about previous temperatures since the areas where they were discovered were originally covered by ancient seas.